So dear students, in this video we will be covering important questions from determinants. We can surely expect a question from this particular topic. So the first question is, show that determinant of this is equals to twice the determinant of this. So right, see, we firstly we have to observe that we have single element in each particular column, right? In column 1 we have A, B, C. That means we only have A here. We have to get rid of either generate A or we have to get rid of B and C here. So we'll do one thing. Let us say column 1, we will apply an operation on the determinant telling that column 1 implies column 1 plus column 2 plus column 3. And if you observe, this is a symmetric determinant because this element is same as this element. So if I do that, what will I get? I get B plus C here plus C plus A plus A plus B. I have to add column 2 and column 3. So similarly for this. And then A plus B plus B plus C plus C plus A. And column 2 and column 3, let me not disturb it. So we get this part. Now, see, this we have two B's here, we have two A's here, and we have two C's here. Can we write this as twice of A plus B plus C? And similarly with this also, can we write twice of A plus B plus C? You can check, you can verify it yourself. We have two A's, two B's, two C's. So with obviously in the third row also we can write this as 2 times A plus B plus C. Then let me write C plus A here, A plus B here, B plus C here, and A plus B here, B plus C here, C plus A here. So dear students, most of you now may think, sir, let us take 2 times A plus B plus C common from column 1, but we will not do that because we only have 2 outside. So I instead of taking 2 times A plus B plus C common, let take 2 common from column 1. I hope you understood this so that I can get 2 here. And what remains is A plus B plus C, C plus A plus B, again A plus B plus C, and A plus B, and then B plus C, and again A plus B plus C, and B plus C and C plus A, right? So now there is a possibility of getting A here, right? How do we get A here? We have to get rid of B plus C. We have to get rid of B plus C. Or we'll do one thing. Without altering column 1, can we just alter column 2 and column 3? That means from column 2, can we get rid of C and A? Answer is yes, because column 2 implies we can say column 2 minus column 1. And similarly, column 3 implies column 3 minus column 1. We can get rid of A and B. So that what do we get here? 2 times A plus B plus C. A plus B plus C, A plus B plus C. Here we get, now here we have to write C plus A minus B minus C. That means C and A gets cancelled. What remains is minus B. So if you have understood this, let me write it directly. In the exam, I recommend you to, show this particular step, okay? In the interest of time, I am directly writing it. Now here A plus B is there. From here, if I subtract A plus B plus C, what remains is minus C. And here, from B plus C, if I subtract A plus B plus C, I get, what do I get? I get minus A. Similarly, what do I get here? I get minus C. And then what do I get here? I get minus A. And what do I get here? I get minus B. I hope you understood this, right? Now we got minus B and minus C. But we want B. Okay, let us take care of that also. Now we'll do one thing before we proceed. We will add column 2 and column 3 to column 1 so that we can get rid of this B plus C. Because A plus B plus C minus B minus C will give us A simply. So we get 2 times A minus B minus C. Here we get C. When I add A plus B plus C and then minus C minus A, what remains is B. Here we get minus C minus A, and here what remains is A plus B plus C minus A minus B should give us C minus A minus B. Now we can do one thing. Take minus 1 common from column 2 and column 3. Okay. So what do we get? 2 times minus 1 into determinant of A, B, C, B, C, A, C, A, B. So ultimately we get 2 times A, B, C, B, C, A, C, A, B. I hope you understood this. So dear students, the question is as simple as that. We can now comfortably write hence proved. Hashtag proved. Now let us go to the next question. Now this is a very, very important question, dear students. And often again students find it challenging. See here, before we proceed into this question, let me give you one simple logic. Determinant of a square can be written as determinant of a into determinant of a. I hope none of you have any question here. So what will I do is, I will take this determinant of a b c b c a c a b whole square. Now can we write this as determinant of a b c b c a c a b multiplied with determinant of a b c b c a c a b? As per this logic, answer is yes, you can definitely do that. And now we'll do one thing. If I directly multiply, now when it is determinant multiplication, we can multiply row by row or row by column. What I mean to say is I can multiply this row with this column also. But if I do that, what will I get? A square plus b square plus c square. But what do I want here? 2bc minus a square. So that doesn't help us, right? See, we want minus a square here. That means somehow or the other we need a negative sign in the first row, right? And how do I get a negative sign? When we interchange two rows or two columns. So we'll do one thing. Let us just try interchanging row 2 and row 3 in this particular determinant. If I do that, what will I get? Determinant of ABC, BCA, CAB. Now we get, if I do that, I'll be getting a minus sign here, right? See, this is into minus 1. This is into minus 1. Because I'm interchanging two rows, the sign of the determinant changes, right? Now, can this minus 1 be taken to the first row? Answer is yes. So we get A, B, C, B, C, A, C, A, B. See, unlike matrices, when we multiply with minus 1, in matrices we have to multiply each and every element, but in determinants it should be multiplied only in a particular row or in a particular column. So I'll be multiplying this minus with the first row. I'll get minus A, minus B, minus C, then we have C, A, B, then we have B, C, A. See, now if you try to multiply the first row with the first column, what will I get? I'll get minus A square plus BC plus BC. That means 2BC minus A square. And exactly that is what we want here. So now we can write minus A square plus BC plus BC. Now again multiply the first row with the second column, we get minus AB plus AB plus C square. Multiply the first row with the third column here. So we get minus AC plus B square plus AC. I hope you understood this. Now for the second row first element, we will multiply second row with the first column. So what do we get? Minus AB plus C square plus AB. Now second row with second column, we get minus B square plus AC plus AC. And now second row with third column, we get minus BC plus BC plus A square. Now for the last row, first element, multiply third row with the first column, we get minus AC plus B square. Now third row with the second column, we get minus BC plus A square plus BC. And now third row with the third column. So we get minus C square plus AB plus AB. So ultimately what remains is, so what are the terms getting cancelled? Firstly, I think minus AB plus AB, minus AC plus AC, minus AB plus AB, minus BC plus BC, minus AC plus AC, minus BC plus BC. That's it. So what remains in the first row is 2BC minus A square, then C square, then B square. And here we are left with C square, 2AC minus B square, and here we are left with A square, and here B square, A square, 2AB minus C square. Dear students, if you have not understood this step, I would recommend you to kindly rewind the video and watch it once again, right? So now we got determinant of ABC, BCA, CAB whole square is equals to this. Let us say this is equation number 1. Now we'll do one thing. Determinant of A, B, C. That means, I think this is what they are asking, right? 2BC minus A square, C square, B square. Right? If you carefully observe the proof, and this question is exactly the same. Now we have to just prove this also, right? Not just that, we have to prove this part also. So for that we'll do one thing. We'll take this determinant ABC, BCA, CAB whole square. Now let us directly expand the determinant along any row or any column, along row 1, let us say. So what do we get? We get A into, I hope all of you know how to expand determinant A into, now this part. Let us take the determinant of this. So it will be BC minus A square, A into BC minus A square. Next we will get minus B times b into b square minus ac. Next, plus c into ab minus c square. Don't forget to place a square here because we have a square here. So ultimately we get a into bc is abc minus a cube minus b cube plus abc, again plus abc minus c cube whole square, right? So we will be getting 3abc minus a cube minus b cube minus c cube whole square. Now can we take minus common here? We can definitely take minus common here. So we get minus 3abc plus a cube plus b cube plus c cube whole square. Now minus 1 whole square is anyways 1. So we can write this as a cube plus b cube plus c cube minus 3abc whole square. Now let us say this is equation number 2. See, from 1 and 2 what can we say? From 1 and 2 we can say the determinant of abc, bca, cab whole square is equals to determinant of, now just write this determinant here, that is 2bc minus a square, and then what do we have? C square b square. Please fill the second row, and that will be equal to this also, a cube plus b cube plus c cube minus 3abc whole square. And now we can comfortably say hence proved, right? That's what I think we have to prove it here. I guess there is a small error in the question. This should be cube instead of square. Okay, this should be cube. Please make a note of it. Now let us go to the next question. I hope you are with me. So next question is also very, very important. It says a determinant of this is equals to 0, and when and this is given in the question, determinant of this is also 0. Then we need to show that abc is equals to minus 1, right? So what will we do is we will split this determinant into two parts, right? How can we split it? We will split along column 3, right? This is the solution. So how do we split it? That means column 1 will be remaining as it is, a, b, c. Column 2 also will be remaining as it is. Now column 3 we will be splitting it like this. Again column 1 will be as it is, column 2 will be as it is. Here we will be getting a cube, b cube, c cube. I hope you understood this step, dear students. We are just splitting the column 3 into, and so we are breaking the determinant into two parts, right? Now what is given is this is given in the question. Don't forget it. We need a square 1, b square 1, c square 1. So this is ready made. We have a square 1, b square 1, c square 1. Can we get the same determinant from the second determinant? The answer is yes. So we will do one thing. Take a comma b comma c common from column 1, column 2 and column 3 respectively of the second determinant. So what do we get? We get first determinant is as it is. So we get a multiplied with b multiplied with c, and then what will be remaining here is, since we have taken a common, 1 will be remaining here. Now a, so I think this should be, I'm really sorry, this should be row 1, row 2 and row 3, right? Yeah. So this should be a square. Now this should be 1 b square, 1 c square. I hope you are with me. See, this is equal to 0 as per the given question. This is 0, right? So don't forget to write 0 here. Now see, here in the first determinant we have 1 in the column 3. So let us do one thing. We will interchange column 3 and column 1. Once we do that, we will the sign of the determinant changes. So let us write that. So what we get here is negative abc. Now column 1 will become a square, b square, c square, a, b, c, 1, 1, 1. Now if you carefully observe, again we need a square, b square, c square in the column 2. So we will do once again, we will do one thing. We will once again exchange column 1 with column 2. So what will we get is determinant of a square 1, b square 1, c square 1. Now again, since we have a negative sign here, negative into negative becomes plus. Since the determinant sign changes once again, so we get a, b, c here, a square, b square, c square here, 1, 1, 1 here, right? So can we now take this particular determinant common throughout? Yeah, so if I take that common, a square 1, b square 1, c square 1. If I take this common, what will be remaining is 1 plus abc. I hope you understood this. See, when x into y is 0, either x is 0 or y is 0, or both x and y are 0. But in the question, So here this should not be equal to 0. The question should be this should not be equal to 0. Okay, please make a note of it. So in the question is telling that this is not equal to 0. This is not equal to 0, right? Let me use a different thing. So since this is not equal to 0, that means here this part is not equal to 0. That means x is not equal to 0. That means y should be 0. I hope you understood this. Now that means this implies we can write, since determinant of a square 1, b square 1, c square 1 is not equal to 0. So we can comfortably say that the remaining part, that means this part, 1 plus abc should be equal to 0. That implies abc is equals to minus 1. I think that's what we have to prove here. We need to show that abc is equals to minus 1. So we can now comfortably say hence proved, right? Now let us go to the next question. Next question says we need to show that this determinant is equal to twice of a plus b plus c whole cube. So very simple, dear students. We will do one thing here. From row 1 we will subtract row 2. What is advantage for that? We will be getting a plus b plus c here, right? So if I do that, I will be getting a plus b. See, from row 1 I have to subtract row 2. So I will be getting 2c minus c. And here a minus b plus c plus 2a, and here b minus b. And row 2. And we'll do one thing. So from row 1 let us subtract row 3. Okay, row 1 let us subtract row 3. You can do row 2 also, nothing wrong. I'm just trying to maintain uniformity. And simultaneously I'll subtract row 3 from row 2 also. Okay, so let us say this is row 3. Okay, so a plus b plus 2c minus c, and here it should be a minus a, and here it should be b minus of c plus a plus 2b, since we are subtracting row 3. And row 2 also we are subtracting row 3 from row 2. So c minus c, and again b plus c plus 2a minus a, and then b minus c plus a plus 2b, and here c plus a plus 2b. I hope you understood this, right? So now what do we get here? A plus b plus c, and here we will get 0, and here we get c b minus 2b is minus b, and then we have minus a minus c. So can we write negative of a plus b plus c? Yes. And c minus c is 0. Now b plus c plus 2a minus a is again a plus b plus c, and here b minus 2b is minus b. So again we get negative of, and then c plus a plus 2b. Now we will do one thing. Now what can be taken common from, take a plus b plus c common from row 1, not just row 1, from row 2 as well, from row 1 and row 2. Okay, so what will I get? A plus b plus c. I'm taking it twice now, so I'll be getting square. You should not write 2 times a plus b plus c. Since I'm taking it a plus b plus c common from row 1 as well as row 2, I'll be getting a plus b plus c into a plus b plus c. So here I'll be getting 1 0 minus 1, since we are taking that common, 0 1 minus 1, and here c a plus 2b plus c. Now the thing is, we can now directly expand along any row or any column. Let us say row 1. So what do we get if I do that? So let us expand along row 1. What do we get? A plus b plus c whole square, determinant of. Now with respect to 1, I have to subtract, is I have to delete first row and first column. So I'll get a plus 2b plus c minus a into minus 1. And next I'm expanding along row 1, right? So minus 0, and then minus 1 times with respect to this. I have to take this determinant now, right? Because I have to delete first row and third column. So what will be remaining is 0 minus c into 1. I hope you understood this. So we get a plus b plus c whole square. Now a plus a is 2a plus 2b. Now c, so minus 1 into minus c is plus c. So we get c plus c is 2c. Can we take 2 common from here? Definitely yes. So we get 2 times a plus b plus c whole square into a plus b plus c. So we get 2 times a plus b plus c whole cube. I think that's what we have to prove here, right? Perfect. So that's it. We can say hence proved. That's it. Now the last question, I will give you this as a homework question, dear students. Please do solve it. We need to get a plus b plus c whole cube, right? We need to show that this is equal to a plus b plus c whole cube. So I'll give you the hint. Hint is row 1 implies row 1 plus row 2 plus row 3. The moment you do this, then you will be getting a plus b plus c here, a plus b plus c here, a plus b plus c here. Take that common, So we will be getting something like this: 1 1 1, 2b, b minus c minus a, 2b, 2c, 2c, c minus a minus b. If I take a plus b plus c common, so we'll be getting this. Now you do one thing: from column 1 you subtract column 3, and from column 2 you also subtract column 3 and then expand. Okay, you should be getting the answer. Okay, after that is done, please do comment in the comment section that it is completed. That's it from determinants. Please do solve these questions, and if you have any doubts, kindly watch the video once again. Thank you for watching.